These are notes for section 7.4. Okay, 7.4, 1 to 25 odd, page 389. The top and the bottom. Okay, and then the answers in the back of the book. 7.4. We have to go up to 25, so I think that's all there. Okay. All right, so in this section, we're doing what I sometimes call hidden quadratics. It doesn't look like a quadratic at the beginning, but upon further examination, it is. So I call it hidden quadratics. X minus 3 squared plus 3 times x minus 3 plus 2 equals 0. Now I notice that x minus 3 and x minus 3 match here, so I decided to call them y. So let y be x minus 3. Then it becomes y squared plus 3y plus 2 equals 0. Much easier. Factor y plus 1, y plus 2 equals 0. Y equals negative 1, or y equals negative 2. But then plug back in, y is equal to x minus 3. So I'm going to say negative 1 is y, which is x minus 3, or negative 2 is x minus 3. So solving x equals 2 or x equals 1. So I make a substitution temporarily to get something I recognize. Number 5, x to the fourth. Think of x to the fourth as x squared squared minus 6x squared minus 27 equals 0. So let y equal x squared. Then it's y squared minus 6y minus 27 equals 0. Factor into y minus 9y plus 3 equals 0. So y is either 9 or negative 3, but remember that y is x squared. So I now have 9 equals x squared, or negative 3 equals x squared. By the square root property, x squared equals 9 means x is plus or minus 3. X squared equals negative 3. Take the square root, so you have plus or minus the square root of negative 3, or I radical 3. So this is my solution. Number 9. For these problems, you kind of want to look to see if there's anything that's pretty much the same, like 2a minus 3. It's kind of a giveaway. And let y be 2a minus 3. Then it looks like y squared minus 9y equals negative 20. Much nicer. Add 20 to both sides. Y squared minus 9y plus 20 equals 0. Factor y minus 4, y minus 5 equals 0. So y equals 4 or y equals 5. Then I change y to 2a minus 3. So 2a minus 3 goes here and here, but that's easy. 4 equals 2a minus 3, or 5 equals 2a minus 3. Okay, so add 3, 7 equals 2a, a is 7 over 2. Add 3 here, 8 equals 2a, a is equal to 4. 13, 6t to the fourth equals negative t squared plus 5. Add t squared and subtract 5 looks like this. So that's sort of like the previous problem. Think of t to the fourth as t squared squared plus t squared. So let y be t squared, or t squared equals 4. So it's 6y squared plus y minus 5 equals 0. Factor into 6y minus 5, y plus 1 equals 0. So that means either this one is 0 or this is 0. So a little bit of algebra, y is 5, 6, or y equals negative 1. Change y back to t squared. So t squared equals 5, 6, or t squared equals negative 1. Square root property, t is plus or minus the square root of 5, 6, or t is plus or minus the square root of negative 1 is plus or minus I. Okay, x minus 7 radical x plus 10. Okay, tricky thing, when radical x is involved, you must check your answer. You might get a solution which is not really a solution, it's a fake solution. So double check your work here. I'm going to write this as square root of x squared. Then I can make the substitution y equals radical x. Y squared minus 7y plus 10 equals 0. Y minus 2y minus 5 equals 0. So y equals 2 or y equals 5. But what's y? Root x. So 2 equals square root of x, or 5 equals square root of x. Square both sides. X is either 4 or 25. But we check them against the original. This was the original. Plug in 4. 4 minus 7 radical 4 plus 10 equals 0. 4 minus 7 times 2 plus 10 equals 0. 4 minus 14 plus 10 equals 0. That checks. Try 25 back here. 25 minus 7 radical 25 plus 10 equals 0. 25 minus 7 times 5 plus 10 equals 0. 25 minus 35 plus 10 equals 0. It checks. my solutions are indeed 4 and 25. Okay, 6x plus 11 radical x equals 35. Think of x as radical x squared, so that's going to become my y again. Y equals square root of x. So 6y squared plus 11y equals 35. Subtract 35. 6y squared plus 11y minus 35 equals 0. Try the quadratic formula. A is 6, b is 11, c is negative 35. So y is negative b plus or minus the square root of b squared minus 4ac. That gives me a double negative, so I change it to positive. All over 2 times a. This comes out to be 121 plus 840. That's 961. Square root of 961 is 31. So I have negative 11 plus or minus 31 over 12. The negative gives me negative 42 over 12, which is negative 7/2. The positive gives me 20 over 12, or 5/3. So these are my y values. Okay? But substitute back y is equal to square root of x. Okay? So square root of x equals negative 7/2. Square both sides, 49 over 4. Square root of x is 5/3. Square both sides, 25 over 9. However, we still have to check. So check back against the original. Okay, if I try 49 over 4, 6 times 49 over 4 plus 11 square root of 49 over 4 is that 35. Okay, well, a little bit of cancellation. That gives me 147 over 2 plus 11 times 7 over 2. Okay, so 147 over 2 plus 77 over 2, you can grind it out. It's not 35, so this doesn't really work. Okay. 25 over 9, 6 times 25 over 9 plus 11 square root of 25 over 9, is that equal to 35? So a little bit of cancellation. That becomes 50 over 3 plus 11 times 5 over 3. 50 over 3 plus 55 over 3 is 105 over 3. That is equal to 35. So my only real solution is x equals 25 over 9. The other solution did not work, so we have to throw it out. All right, so that's for section 7.4.